So let's get this started. So this is a VPN introduction. If you talk about virtual private networks, you're talking about tunneling. And one of the important things is that we want to make it secure. We have several types of VPNs. We have something that I call telco VPNs, which use Q&Q VLAN. I will talk a lot about IPsec. I will talk a little bit about other VPN protocols. I will also include our own solution, the ESG 5110. You can ask questions at any time, and hopefully I will notice them in the chat box. And well, it's only 1 hour. I'm not sure how much of the time I will take, but in any case, I will be skipping a lot of stuff. So it will be just an introduction. It will be by no means complete, but I will hope to have touched most of the bases, or the basic things at least. So first, let us talk about making it secure. If we're talking about security, we're always talking about the so-called CIA security triad. So when you talk about CIA, most people think about some American thing, but I always think about something else, which I find very funny. In any case, so the C stands for confidentiality. That is about outsiders not being able to read your things. So that it being in an envelope. By using and enforcing encryption, SSL, TLS, etc., and or using encrypted VPNs, you can make this happen. The other thing is about integrity, and that is that outsiders cannot modify your packets, delete it, or if they do, that you at least will be aware that it is happening. And this is usually done by using stuff like checksum, sequence numbers, and also in some ways using a stateful inspection firewall. And then last thing, which is part of the CA security triad, it's about availability, that others cannot interrupt it, or when something happens, that you have multiple redundant paths, multi-one, self-healing VPNs to recover your link. Just keep these in mind when we're talking about VPNs. So next, I will just talk about the telco VPN. I'm not sure if anybody is aware of this, or if many people are aware of this, but often if you talk to your local telecom provider or ISP, they are able to make something like this. So what is, say, Q&Q VLAN, which is what they are using for this? That is that they are using switches that are able to prepend VLAN tags to your own VLAN tags. So your network is connected to their network, and everything, including any VLAN tags that you have, can be put in another VLAN and then passed on. So maybe you just have normal packets. Maybe you have packets that already have a VLAN tag. Then when it goes to their switch, they will prepend your VLAN tag. So every company that has such a telco VPN will have their own tag or set of tags. And well, one of the other things that it does is usually you only have something like 4,000 VPNs, but in this case, you will have 4,000 times 4,000 VPNs, or if the telco needs more, they can even do a double Q&Q to create even more VLANs. to use for this kind of application. So although this is a layer 2 feature, if you will find it in anything, you will find it in some layer 3 plus switches, telco switches, or whatever you want to call them. The other thing is, of course, this is done in the hardware of the switch. So it doesn't need any CPU cycles to make this happen. And this makes it possible to do this at line speed, be it 1 gigabit, 10 gigabit, 2.5 gigabit, 40 gigabit, 100 gigabit. So you can have really fast connections this way over long distances, as long as you stay within the coverage area of the telco or ISP that is offering this service. And this is made possible by most telcos now having their own Ethernet backbone, and customers are connected to switches instead of in the past the AT&D slams, which were using ADSL. And the switches that the telcos are using either have VDSL, they have real Ethernet, or most likely they will have fiber interfaces on the customer edge. And then on the inside, they will have fiber uplink or trunk ports with higher speed. So if these are 1 gigabit or maybe 10 gigabit on the customer edge side, they will be 10, 40, 100 gigabits uplink ports. And of course, in this case, these switches need to support the Q&Q VLANs, like we discussed before. So in the end, this makes it possible if you connect multiple of your offices of your enterprise to the same VLAN, same telco VLAN, then you will just have a bridge network between your all your offices. You do not. It will be a flat bridge network. Of course, this is a choice you can make. You can still put a router in between and make it do NET if you wish. So the benefits here is that you have high throughput, low latency, as it's depending on the distance, of course. If you are able to do this over 100 kilometers, you will have a few milliseconds latency. If you're in a big country and a big telco is able to deliver this over long distances, then your latency will go up, of course. It might even have high availability due to the telco infrastructure having supporting rings like that, so that if one link falls out, it will reroute its traffic without you even noticing it. And it's layer 2 totally transparent bridge traffic for you. The drawbacks is you have no confidentiality. At least anybody in the telco could make packet captures of your packets, and they might be even able to mirror modify the packets on the backbone, so you have no integrity. And the other thing is that if you have this, usually this is only something that enterprises have because the price is usually pretty high. The telco or ISPs do need their own infrastructure to support this, and they're often using this to support virtual ISPs. So ISPs without their own infrastructure. Another thing I want to mention is, well, point-to-point wireless. In some sense, you can also call this a virtual private network. It does exactly the same as the Q&Q stuff. You bridge two networks together. And if you use encrypted links, you will have more integrity, more confidentiality, but at least in my experience, high availability for these kinds of links is pretty hard. So then we come to the thing that everybody is expecting. the VPNs over Ethernet. So you have an Ethernet link. You do not have a very costly Q&Q telco VPN. You just have an internet link, or maybe two internet VPN links. But still, it's hard. It's hard because on your customer edge, you usually just have a single IP, and you need to encapsulate your Ethernet packets. Then your one IP, if you're lucky, it's static, or at least you always get the same one. But it is not always the case, and in some cases the IP address may change every day or even more often. There's one way around this, and that is the using of the dynamic DNS, so that you will have the same host name always, and the IP address associated to your IP address. The IP address associated with your host name is dynamically changed every time your public IP addresses change. The other thing, of course, is that your packets need to be encrypted for confidentiality, which will cause a CPU load on the device that you're using. And the packet checksums need to be validated for integrity. Probably a little bit less high CPU load, but still. And again, high availability here is also challenging. At the very least, you need a dual internet connection. And for those two dual internet connections, if you use the same type of connection from the same provider, using the same infrastructure, it's probably not a good choice. You want to have the least possible infrastructure overlap. And lastly, it's nice to have some redundant router hardware. So those are the things about that. Then we can distinguish two main types of VPNs. The site-to-site VPNs, and also, and in that, the hub mesh VPNs, spokes, and the other main type is the client VPNs, or remote access, or for remote access. Then we have a lot of different encapsulations that can be used. Well, to name some, of course, IPsec, the one that we will talk about mostly, some others, and then, of course, we talked about the Q&Q before, which I also want to keep in this list, just because it might be a very good solution in some cases, if your telco can provide this. Of course, I prefer you to use IPsec with our devices, but okay. The Q&Q, maybe you can use it with our switches too. So about site-to-site, this is when offices and brand offices have internet connections. You can use the VPN to join your local area networks, or at least make routing possible between those local area networks. When you do this, the network traffic can be routed, and this is important to note if you're talking about IPsec, that one is always routed. Important to remember is that routing is only possible if all destination networks have unique subnets. So if all your subnets, all your routers are still using their default subnets, which often is something like 192.168.1. something, then if they all have that won't work. And if you have our devices which have the 66 network, if they're all still on the 66 network, you cannot route either. So you need to make some changes there. That said, in some routers, it's not supported by ours, but some routers are able to do network address translation inside the tunnel. So when the traffic goes from one side to the other side, fake the remote IP addresses. But from my perspective, this is not a solution. At best, you would call it a workaround, and it is, if there's any problem, it's so hard to troubleshoot. So renumber the conflicting networks is the way to go. Site-to-site VPNs, of course, you need the VPN gateway on all the ends that you want to connect. And if you're talking about something like a mesh VPN, there is a limit on the number of VPNs that you can make with any one device. So you're limited to that. In the simplest form, both sites just need to be configured with the prefab key, correct public IP address to the gateways, some local remote subnet and ranges, and all the rest can be left the default. And instead of the prefab key, some devices can use certificates. So about hub and spoke VPNs. In some cases, I'm thinking about banks, for instance. They want to route all the traffic to their central gateway and inspect the traffic there, and then put it to the internet. In that case, you will have the central site as being the hub, and all of the offices, the remote offices, as spokes, all the branches. So only the hub will have multiple connections, and all the other sites will have a single VPN connection. And if they need to connect from one branch office to another branch office, they will need to do so through the hub to the main site. And in this case, so you might need a very simple VPN gateway on the branch sites, but a huge one on the central sites, which supports enough VPN connections. In the case of a mesh VPN, everything is connected to everything. So if you have 10 sites, every site will have 9 VPNs connections to connect to each of the other of the 10 sites. So this is limited by the number of VPNs that the device supports. So if the device only supports 5 VPNs as a maximum, and you need to have 10, then a mesh VPN will not work in that case. So the next thing to talk about is remote access client VPNs. So this is different from site to site. This is just that you're working in a home office or on the road, or even some small bench offices. You use some software or to some settings on your OS to connect up to the central site VPN server. If you talk about IPsec VPNs, these are usually paid software, but the upside is that these are much easier to configure and often more secure than some of the alternatives. You need to have this set up on your central site to make it work. And in simplest forms, you just need to configure the correct public IP host name of the VPN gateway, a pre-shared key, and yeah, hopefully just the other stuff will be default. Sometimes you need to install again here certificates to set up the connection. One additional thing that you might want is that the user also needs to type in some user credentials, a username and a password, to allow the VPN to connect. One of the ways to do this is using EAP, Extensible Authentication Protocol, or one or its many derivatives. This allows VPN clients to authenticate themselves in a similar way to what you see with WPA Enterprise on wireless access points, or 802.1.x on switches. If you want to use this with IPsec, you need to use IKE version 2, Internet Key Exchange version 2, because version 1 did not support this. And then some of these solutions, you can also combine them with two-factor authentication. So two-factor authentication, multi-factor authentication, this is an additional security measurement that you might want to put in during the connection, during the setup of the connection. The user needs to do some additional authentication. This can be typing in additional code, which can be provided by a dongle, smartphone app, a physical list received by email or by SMS, or by pressing a confirmation button in a smartphone app. Another thing that you need to think about is that you still, with the VPN gateway, it's a firewall usually, so you will have outbound and inbound rules, and they might be all open for all set to forward, but if not, you need to set it up correctly to make the right things connect, and also put in some block rules maybe for things that you do not want to happen. Maybe you do not want people who dial in to also connect to branch offices. Maybe you do not want branch offices to do site-to-site connections, but only to the main office, and maybe only to selected services on the main main site. Okay, that's very generic. And now to one of the longer parts of my my thing, IPsec. So IPsec, or Internet Protocol Security, it works on layer 3, and usually when you have it up, it's just like another network adapter in your computer. So your computer doesn't really see that it is making a VPN. It's just another IP link that it has. So to set up the connection, first you do some steps, and for that IPsec uses the Internet Key Exchange, version 1, version 2. This is used to create temporary symmetric encryption keys. So you have your pre-shared key to start with, or your certificate, and you could theoretically just use that to encrypt your stuff, but that would be very static. So what you do is you do it in steps. First you take your pre-shared key, and you do some magic, and then you have a temporary symmetric encryption key. And after that, you use that again to make the next key. So there are two versions of IKE, version 1, version 2. My advice would be only use version 1 if you must. V1 supports a main mode and aggressive mode. If you need to use V1, just use main mode. Aggressive mode may be faster, but it is less secure. And also some devices do not even support it, like our ESG. So IKE V2 supports credential-based connections, which V1 does not. That only does pre-shared key. And another thing is V2 is can be faster in setting up connections, because for a very basic connection, it needs fewer setup steps. And yeah, it can be made more secure than V1. So whatever you're using, V1 or V2, it uses a UDP port 500 to set up the connection. And if you have any in between NET routers, that needs to be forwarded somehow to your IPsec router. So with the connection setup, I'm going to discuss mostly V1 because it's a little bit simpler, and if you know how that works, V2 is not that much harder. So for V1, you have two steps. First, you do phase 1, which is about your all the site on the everything on the internet side of your device, and you create a key, an encryption key for that. And in the end, you use that encryption key to do the second part, and that is figure out all the local stuff in phase 2. And also, then you create a second key. So you have the first key to keep everything secret within the phase 1 stuff, which you use to set up the phase 2. And the second key is the one that you will use to encrypt all the data. Depending on the device you are using, you will see that the phase 1 and phase 2 are configured in the same screen, and then you might not be able to configure a secondary or local or remote networks. The usual workaround is to just create a second site-to-site tunnel with identical phase 1 settings and the different secondary remote LAN stuff, or use supernetting. So both phase 1 and phase 2 are periodically repeated. You have a lifetime that you can configure, which is in hours, and each time this happens, new session encryption keys are done, and these are symmetric, which is important to note. That is just because of speed. You could have asymmetric encryption here also, but that's only used for the setup. After that, you will use symmetric just to make it make it faster, or maybe I should say less CPU intensive. One more thing that with the whole what's done here is the so-called dead peer detection. This is used to detect if a tunnel needs to be restarted. With the first IPsec gateways that I have worked with, the IPsec standard at that time did not have any dead pair detection. And when somebody powered down a gateway on one or the other side, then the other side would just stay on because the lifetime didn't elapse. And when the other one was powered up again, it would just be ignored because the VPN was already up. And you do not want to know how many cleaning ladies produce this error by removing the power from a gateway just to put in their vacuum cleaner. It happened a lot. Anyway, they added dead pair detection, and this is a short ping to just check if the other side is still there. And if it ceases to answer, it doesn't say that it's alive, then it will assume that it will then it will just restart the phase 1, phase 2 again and fix that. I'm seeing a question here. Let me see. This is I think this is let me see where I had that remark. I will get back to the multiple networks question later. Okay, so we have this part, that pair detection explained. So for V2, it's called different, but the EKE's SAE in it is comparable to what you have in phase 1 of EKE V1. And then you have the EKE out version, which does more or less the same as what you see in the phase 2. But if you have multiple networks, then it will do a create child security association for each additional subnet. Usually when you have this, you will it depends a little bit on the in the interface of the device, how you will configure this. So in some devices, you can configure phase 1 in one screen, and then you have separate phase 2 configurations, or maybe I should say a separate screen to configure all the local settings, your local networks on either side. And then in those screens, you can you have a drop down and say to which phase 1 it is connected, and you can have multiple phase 2s or child SAs, and that way connected to the single phase 1. I think that in our device, there's actually additional fields that you can use to put in all the things. And when you make a change, when the link is already up, yes, probably as soon as you apply the change, the whole VPN will go down and it will come up again, doing the phase 1, phase 2, or EK's SA in it, EK out, and create child SAs after that. So the pre-shared keys or certificates themselves are never exchanged, because then people would see them with Wireshark or something, and then know everything they need to know. But they are used to create a phase 1 security association, and then another thing to encrypt the phase 2. And this is usually done, but with what EKA, at least in IPsec, EKA is used. So each of the security association will have a expiry or lifetime. Usually this is a multiple of 8 hours. Shorter is safer, but it creates more overhead. And depending on the device, in the past, I noticed that every time it expired, you would have a small time, a noticeable time that the link would be, the VPN link would be down. Also, it makes sense to more or less synchronize your phase 1 and phase 2 security associations. Often you see it that it's the same time, but of course, the phase 1 security association is only used for a very short while to make the phase 2 security association. So very little data. So you might consider doing the phase 1 to 24 hours, for instance, and having the phase 2 to 2 hours, 4 hours, or 8 hours, or something like that. Again, shorter is safer because if people have more data, there's more chance that they can decrypt it. And also, if they take 8 hours to decrypt something, and you already changed your key, they can only look at your old stuff. In some situations, that might be interesting, just to have it secret long enough. So in any case, source IP address, public IP addresses are checked. The protocols are checked, and yeah. I think I doubled that one up. So obviously, if you have something like a one-click VPN or auto VPN, there is little to go wrong. All settings are automatically set to correct, but you may want to know the effects of some of the hidden settings that are used in this case. If you need to configure, you have lots of settings that you need to either make the same or mirror them. And to give you some idea, so if you have 2 VPN gateways, of course, you need to have the same protocol. They need to be the same mode. pre-shared keys or the certificates need to be the same or compatible. You need to have the same security assertion lifetime. Yeah, well, I say must be the same. I think I could say should be the same, because if the one wants to change it, your dead peer detection will kick in in the worst case, and then it will come back up. Ideally, it will be the same. But things like the local and remote IP addresses, those will usually be need to be swapped. The remote, again, also need to be swapped. And so there are some of those in red, which need to be swapped, and all the other stuff that must be the same. So it's mostly IP addresses that need to be swapped, and all the other stuff is just the same. And if you have something like extended authentication protocol, of course, for a site-to-site VPN, that will be disabled because that is not what you're using for it for. You will only use that for clients. So you can see that there are lots of 000. Depending on the device implementation, if there are zeros, it's often that it's auto-filled or something like that. And in the case of the DNS, that can be any strings. Possible encryption settings, you can choose a lot, but you should not use DES anymore because that's not very much of encryption. It has lots of weaknesses and it can be hacked. Authentications, you have lots, but MD5 you shouldn't use. SHA-1 you should avoid but in some cases it may be the only thing that you have, so then you have to use it. And we also have stuff like that's called possible perfect forward secrecies. There are many differences, and again, higher is better, but maybe it's not all supported by your device, so you have to choose what you have. So I talked about setting up the VPN. Now we have the VPN set up. Both VPN devices are happy. They know each other. They have their keys, and now they need to exchange the packets. Somebody sends a ping from one side to the other side, so then it needs to be encapsulated and transported. So with IPsec, we have two types of things we support: authentication header, both tunnel and transport mode. And authentication header is protocol 51. So this is a protocol like ICMP is a protocol, UDP is a protocol, and TCP is a protocol. So those are protocols 1, 6, and 17. So these are also protocols. And the same ESP, that's the other one that's using protocol 50. So although I will talk about the authentication header, I will show why you're probably not going to, well, you're not going to use it ever. So one of the problems that we have with these being protocols is that not all the NET routers support protocols, more protocols than ICMP, TCP, and UDP. So if they see something like protocol 51, protocol 50, protocol 47, whatever, they will just drop it. Because of this, we have something what we call NAT traversal. And in that case, for the ESP, it will change protocol 50 or put in a UDP header, which all NET routers will support. And then you can get your packets through. Important note to make here is that if you do this, you want to have it enabled on both sides. If you only have it enabled on one side, it actually sometimes works, but you should not expect it to work. A downside to using NAT traversal is the reason that we're using protocol 5150 is to reduce the amount of overhead. But with NET NAT traversal, we insert some additional IP bytes to put the UDP thingy in, so it makes it less efficient. Your maximum packet size that you can put into the packets, given your internet MTU, will be a little bit less. So with transport mode, the packet will not be getting a new packet header, no different destination source IP. So in fact, this will only work well when you have no network address translation in between. Well, maybe that's not exactly the reason, but you will see soon what's the problem with it. And in practice, you will only have this when you have do this inside your own network, or if you are using IPv6, which has enough IP addresses for every device to have this own public IP address. With tunnel mode, the packet will be encapsulated with a new packet header. So it will keep the old packets in the packet, but put in another new packet header in front. Then get next thing, if you have authentication header in tunnel mode, the IP header is authenticated. Well, actually with authentication header, yes, it's talking about authentication header, it will always authenticate your header, regardless if it's in tunnel mode or in a transport mode. And that is the reason why it will not work in NET, because NET will change your header, your IP header. It will change your private IP address to public IP address, and then the header will no longer be correct. So this will be broken by NET. In ESP tunnel mode, this can work even when there's NET between the two endpoints. And that's the reason why we actually just always use ESP tunnel mode for VPNs. And not just point-to-point VPNs, also for client VPNs. So I have some colorful pictures here. So this is about authentication header. Here you can see your original packet. Then you put in your authentication header, make a transport mode, and then you see that everything is authenticated. There are some things that are changed, like your TTL field. Every time it passes through a router, TTL is lowered by 1. And of course, if that would also be part of the authentication, then it would always fail as soon as there's any router in between, which is sure to happen for the internet. So those kind of fields are ignored, but otherwise all the fields like the IP header is checked, and if something has changed, it will be it will just drop the packet. With tunnel mode, again, the same will happen. It will also check your new IP header, and going to an NET, that will fail. So yeah, you should avoid using a authentication header. I write here. Yeah, you cannot use authentication header in practice. So then for ESP, we get something a little bit different. This encrypts, again, puts some stuff in front and at the end, but you can see that only the ESP part, or your packet and your ESP trailer, is encrypted. And the authenticated part, you know, again, maybe CIA authenticated, the integrity part, it's not including the IP header. But in this case, if you put it through an NET, you will break it, because it will no longer it will go wrong here too. So you need to use tunnel mode, and then you have your original IP, and you have your new IP header, and your new IP header will just contain the IP addresses of your two gateways, so on your two endpoints. And again, you will only encrypt the data part and authenticate it from the ESP header on. So this part needs to be intact on the other side, and then it's okay. Now, I talked about NAT reversal. If you do the same with NAT reversal, then you will get another few bytes in between. And in this case, this first part, you have your MAC addresses, and you have your IP header, and you have your NAT. It will just appear to be a UDP packet for any router in between. So if it understands UDP and all NT routers understand UDP, it can just pass it correctly and not break it. Looking Wireshark, this first, the top one, that's the pack as a packet, and it doesn't show any content, just that it has an encapsulated security payload with an SPI. And then the second part, because we have all the knowledge like prescribed keys and stuff like that, we can take some steps and we can disassemble the or decrypt the packet. And then you can see again here for this exactly the well, it should be the same for the same ESP SPI. Now you can see that it is a ping that is actually going here. I got this example from Wireshark, and I managed to even decode it with the information that they gave. If you look at the printed version, the PDF that I put in the handout section, then you will see how I configured Wireshark to do this part too. So this was before I did anything, and this was after I put in the right security association stuff into Wireshark to decode it. So some of the common IPsec VPN debugging experience that I had. The main thing, of course, is the tunnel doesn't come up. It doesn't work. Well, they always say it doesn't work, and then you need to ask. So the first thing that you need to check is if the other side is even reachable, because ISPs do make mistakes. And in some cases, the ISPs don't route your ISP packets. They drop ISP. They check that it does ping. Then are the your IKE packets sent and received? Sometimes you forgot to enable your thing, and it's sent out. It's not sent out at all. Or when you look at the packet trace, you're seeing that you're sending out to the wrong remote IP address, and in that case, it will never be received. And on the other hand, if it's being sent out, is it really actually being received and not winding up in Dubai, like I had with one case? Because there was a IP address assigned both to the Netherlands and Dubai at the same time, and it was a little bit 50-50 where the packet wound up. After the ISP changed the public IP address of this customer, that problem went away. So if it receives it, then next question is, does it even answer? Yeah, again, you need a packet capture for that. Then if it goes on for partly, you can see it in the packet capture. If it's, but also in the device log, is it a phase 1 issue or phase 2 issue? This, you want to know this because you want to know if you need to look at the first part, the phase 1 part, that you need to make some changes there, or that maybe the mistake is in the second part. So knowing that it passes phase 1 and stops at phase 2 makes a lot of sense. And then sometimes the tunnel is up, but there's no data. Well, the most obvious things to check is maybe you have some firewall rules. So in this case, people test and they ping from one computer to a remote Windows computer, and then they complain that the remote computer does not answer. Yeah, well, Windows computers by default, from I think Windows 7 or something, they have ICMP ping blocked by default. So maybe your tunnel is up, but your pingers are simply not answers because of the Windows firewall. So important to take that into account. Firewall rules on the VPN gateway you need to check. And of course, are you behind NET, network address translation? Maybe the router doesn't understand ESP, or maybe you need to do some port forwarding. But again, you would probably find out that you need some port forwarding in the first part already. Anyway, if it's behind NET, maybe you need to enable NAT traversal. And if it's symmetric NAT, you need to do that for sure, because it will not work otherwise. And if you have some cone NET, again, you need to have this enabled, either by auto VPN, or you need to do some port forwarding. So that's what I'm going to tell about IPsec here. Then for a very short thing, other things, we have PPP, which we use inside stuff. It's not a VPN protocol by itself. We have GRE, usually not used by itself, but it's used by PPTP, LTTP to encapsulate data, and by Internet over GRE also. Microsoft PPTP don't use. It has also been removed by a lot of stuff. SSTP, some Microsoft standard. It uses port 443, but nobody else is using LTTP. The strange thing is I found out that Android 12 removed support for this recently. So it's being removed. We have OpenVPN, which is pretty common nowadays and supported on all OSs. And we have FWireGuard, which is sort of the new kid on the block. Doesn't use pre-shared keys, but well, actually it uses two pre-shared keys, a public and a private, and something called noise protocol instead of EKE. And it's limited to modern, safe encryption choices. So you have more choices with IPsec, and I think the most important thing to note is that this it should be more efficient and faster than IPsec. From what I'm seeing here, it's about 20% faster in speed, 10 to 20% faster in speed, and it has a slightly lower latency than IPsec. The important thing to note about both OpenVPN and WireGuard is that in our solution, those will be implemented in the future. They're working on them now. So I see. Oh yeah, I try to make a table, and basically, if you need to have any type of VPN, you're sort of stuck between IPsec, OpenVPN, and WireGuard, unless you have a lot of money. Also do Q and Q, which might, in combination, might be the best thing. But this is my guess. I think there's always things to say that might be different.